Welcome to this Scada workshop, which is called Industrial Control Systems Pentesting PLCs 101. So just a quick reminder, that means that it's going to be an introductory class. Do not expect any ODAs this afternoon. The goal is to give you some knowledge about how you can pen test those devices, what is specific to those devices, what attack techniques you can use. So basically that's the point. I'm sorry we start a bit late, but we have some issues with let's say the hardware that I bring. Some things broke during the travel. Just 10 seconds about me. My name is Arnaud Soullie. I'm French. I work at Solucom, which is a French management and IT consulting. Obviously, I work in the IT part. What are my interests? I work in security, mostly as a pen tester. So I perform all kind of web application penetration tests, network penetration tests, thick clients, and also industrial control systems. I have a specific interest in Windows Active Directory issues. I gave a talk at a French security conference earlier this year, so that there's actually a mistake on the slide. It was this year, not last year. And also I like wine a lot, but this topic will not be covered today. Okay, so this is a workshop, so I expect you to ask all the questions you want during the workshop. No need to wait until the end. There's going to be two parts. The first one would be about, let's say, an introduction to ICS. So it's going to be mostly slides. And in the second part, I will give you a virtual machine with some exercises to do. Firstly on simulators, and in a second time, we're going to try to access those devices and try to understand how we can put them. So I will give you USB keys. It's VirtualBox virtual machine, which is Kali Linux. I think most of you should be familiar with this Linux distribution. It's used for penetration testing. I put some additional tools specific to the ICS, so you will find Modbus PAL, MPTGet, PLC scan, Snap7, and also some Metasploit modules, and also some PCAP samples and some script that I wrote. So I have the USB key just here. What I suggest is that you copy the virtual machine and you try to install it during the first part, so when you come back after the break, everything works. I'm low on USB keys, but please share it with your neighbors. Okay. There you go. Yeah, that's a bit sexier. Okay, so as I told you, there would be two parts. One mostly with the slides. It's going to be the ICS introduction and some specific knowledge about the Modbus protocol, and then the last part, attacking PLCs. So I'm going to give you a quick word about what a PLC is right now. So here we have two different models. This one is from Siemens. This one is from Schneider. And those little devices are used in most of the plants or factory to allow automation of the process. So depending on of the inputs, the value of some sensors, they will process this information and perform some kind of actions with their outputs, basically. Okay, so let's start with the introduction. What is an industrial control system, an ICS? So let's say it's divided in several parts. The lowest level one is what we call the production network, on which you can find sensors and actuators, which are basically the inputs and outputs of the PLCs. You can find some wireless networks. Most of the time, it's let's say a classical Wi-Fi network. Sometimes some specific proprietary tools can be used also. We can also find some RTUs, which means remote terminal units, and it's used to remotely access. It's kind of a PLC, but meant to be used remotely. Then we have the supervision network. That may also be called the Scada network, on which you can find workstation with the supervision software installed. So this is where the operators, the people working at the plant or the factory, let's say they manage the process. You can also find some kind of laptops used for maintenance. For example, the people working take the laptop with them and they connect directly to the PLCs or to other kind of device on the field. And of course, you have some servers. Some are dedicated to the Scada supervision software that you use, and some servers are quite specific and are called data historian. Their purpose is to store all the data from the process at all the time in order to be, let's say, analyzed later. So what we call ICS is basically the production network and the supervision network. Most of the time, everything is somehow connected to the corporate network, where you can find, let's say, all your application, the user's workstation, because most of the time, some data needs to be taken off the supervision network, for example, from the data historian, and to be fed into some specific application in the corporate network, for example, in SAP or any other kind of ERP. That allows the people to, let's say, try to have a better process to be, let's say, to be more efficient. So, as a conclusion on this slide, basically, what I would like to say is that you have to understand that corporate information system only handles data, whereas what we call an ICS actually interfaces the data with the physical world. So that means if you perform, you send some packets, some real things will happen in the physical world. That may be a light that will be switched on or off, or any kind of physical action. Next, just a bit of vocabulary, because I think it's important. ICS stands for Industrial Control System. I'm going to say that at least 1,000 times this afternoon. It's exactly the same as IACS, which means Industrial Automation and Control System. And as we saw earlier, it's quite different from Scada, which means Supervisory Control and Data Acquisition, because Scada is only one part of let's say the ICS. And it's also different from DCS, which is another kind of, let's say, process, plant processing. However, what is also important to know, today, most people tend to say Scada for ICS. So if you encounter one of your clients that says you want a Scada assessment, that could mean anything from the ICS. That can be the PLCs, the production network, or only the supervision software. That's, let's say, the trend today. Okay, if I continue, I will detail let's say, the role of the key components that we can find in an ICS. Please feel free to interrupt me if I forget something, or if you know any kind of device that you can find. So the first kind of device is what I called earlier the sensors and the actuators. So as I told you, these are the most low-level things you can find. So basically what we call a sensor could be some kind of switch like this one, and an actuator is something that performs an action depending on the information that is sent to him. So on this picture you have a valve. So let's say you send some electric signal to the valve and it shuts off the valve, or maybe it opens it. Next type of thing you can encounter is what we call a local HMI. So it means human-machine interface. So over here, we have one from Siemens. So let's say most of the time the plants or the factory are quite big, so the people are performing the supervision from one central room, but they also need to have some information when they are on the field, so near the process. So in most of the plants you can find those tiny screens. Sometimes there are touch screens, sometimes there is only some buttons. It allows the operators to have some, let's say, some information about what is going on, or maybe before doing some kind of operation they can shut down the process locally. So that's quite important. PLCs, which are, let's say, the subject of today, that means Programmable Logic Controller. It manages all the sensors and the actuators. So for example, on the picture, it's also a PLC from Schneider. If we take a look here at this PLC, you will see that, I'll come back to that later, but just quickly you can see that there is the power. That's what we call the CPU, so it processes the information, and then we have an input-output card that allows to interact with the sensors and the actuators that I mentioned. Supervision screen. So as I just told you, most of the supervision in the plants or factory is done from a big room where you have those kind of big screen with the green or red light depending on how the process goes. So that allows the people to have a high level overview of how the plant or the factory is going. And then again, data historian, that's a server, so I didn't put any picture of server, but more a picture of data. It recalls all the data from the production networks and allow this data to be sometimes forwarded to the corporate network, where when the people crunch all this data to, let's say, to try to make the process more efficient. Or in case of incident, if something goes bad, they can analyze the data and see where the problem came from. Any questions so far? Okay. Next, let's say a security awareness timeline from Scada systems. I think it's important to understand there's quite a big shift nowadays in Scada awareness. So before 2011, let's say nobody cared about Scada security. That's mostly right, except from specific industries, maybe in the nuclear production. They were doing some security, but most of my clients never asked or never mentioned the security of ICS before that, before 2011. Then, oh my God, Stuxnet. Of course, that was kind of a big deal because it made it to the news, and not only the specific IT or security newspaper, it was all over the place. So that was, at least for me and for my company, quite of a game changer, because we were asked a lot for ICS assessments and for, let's say, ICS consoling. And maybe one day, as we do today for some of the corporate networks, we'll have some fancy dashboard that truly means nothing about the security level, but at least you have something. Okay. So let's continue and let's try to find out what is wrong currently with the level of security of ICS. So that's mainly based on what I've seen. Please feel free to join in the conversation and add some things or tell me if I'm wrong. So, well, the first part would be awareness and organization. From what I've been able to see, most of the time there is no security awareness for people working in the ICS field. They care about safety, which means the safety of the people working in the factory, the safety of the people living nearby the factory, and also they try not to pollute the environment, but that's what we call safety, and it's quite different from security. So they think a lot about what could go wrong in the process in terms of the safety of the people, but they really not take into account the fact that someone could maybe remotely access the ICS and do some bad things. Also, it's kind of hard to find someone to talk to concerning security when you visit a plant or a factory. So in corporate networks, most of the time we have chief information security officers. That's not the case for most ICS. Locally on the plant or factory, sometimes only a few people are knowledgeable about IT, and that does not include security. So that's also kind of a very big deal. Next subject, the network segmentation. We're gonna deep dive in that later, but let's say that from what I've been able to see, most of the time, as I told you, some data needs to get out of the ICS to be fed into some kind of network applications. Most of the time it's done wrongly. That means that sometimes you put some ICS devices on the internet. That means that sometimes all your corporate network can access all the, let's say, web interfaces of all your ICS. So when we're talking about big companies that have maybe 100,000 employees, that's too much, clearly. Sometimes the network segmentation is only done using, let's say, some access control list on the router. There is no real firewall. There is no real DMZ or data diode. So let's say if an attacker can breach into your corporate network, and if there are some pen testers over here, I'm sure they know that it's quite easy. It's also quite easy to jump from the corporate network to the ICS network most of the time. Vulnerability management, also a hot topic. Let's say it's not easy to do vulnerability management right in the corporate network. It's quite harder in the ICS world. Most of the time, let's say for the PLCs, there are some security updates. So you have to update the firmware. The problem is that when you want to update the firmware, you have to turn off your industrial process for a moment. So let's say you have 100 PLCs, maybe your plant needs to be shut down for 1-2 days or maybe a week, and then that's a big loss of money. Most of the time they run 24/7, so it's not possible to apply the patch during the night as we can do in the corporate network. So yeah, patches are published but rarely applied. If we talk about the, let's say, the classical IT component like Windows, let's say Windows XP or Windows 7 workstation, since the ICS is not directly connected to the corporate network, you do not benefit from the WSUS systems, for example. So yes, even the Windows machines are mostly not patched. Excuse me, do you have a question?
Yeah, question. You actually include in this vision also the typical smart metering structure?
No, actually no. I'm mostly talking about factories and plants, not the smart meters. Okay. But I'm sure let's say the security problems must be the same, but I've never assessed security, let's say smart meters, so I really don't know. But there was a great talk yesterday about that. It was really interesting.
Actually, the problem of the update of the firmware
is
basically on millions of smart meters at the same time.
Yeah.
So actually the scaling problem are different, and there might be a solution of automatic update in some cases.
Yes, but then you have to be sure that let's say the update mechanism is secured, because as the people who did the talk yesterday mentioned, they were able to let's say create some kind of worm that will spread itself by modifying the firmware of each smart meter.
Oh, just understand what was included in this.
Okay, so that's mostly the industrial control systems you can find in plants and factories. Yeah, let's continue with the security protocols. So as we will see later with Modbus, most of the times there was no security included into the protocols. So that means no authentication, clear text protocols. So let's say once you have network access, you basically have the possibility of doing everything that you want, which combined to the fact that the network segmentation is loose, that's kind of a big deal. Just a quick word about the third-party management. in most of plants or factories that I've been to, there was a lot of, let's say, specific devices managed only by a third party. So the client had to let the third party come, connect his specific computers, maybe his USB key, or even allow a remote connection to that specific device or to the whole ICS to allow remote connection and debugging. And if you do not agree with that, then you lose the support, and then you cannot take that risk. So that's also a big deal. And the next topic is security supervision, which is a hot topic in the corporate network. Most of the time, people try not to focus only on protection, but also on the ability of detecting any security breach and responding to it. Funny thing is that, let's say, ICS and Scada is all about monitoring, but it's monitoring a process. And it's quite different from monitoring the security of a process. So the capabilities of the PLCs and other devices that you can find in terms of logging are most of the time quite low. And at the moment, I've never seen someone performing a real, let's say, syslog on ICS and correlating the logs. I think maybe in a few years we can see that, but at the moment I've never seen it. Any question? Yeah.
Are we also talking about really small-scale systems, like, for example, swimming pool control and public swimming pool?
Yeah, but also for let's say private swimming pools, you can find some private swimming pool on the internet. Yes. Yeah, that's true. Actually, if we take a look at those devices, the Schneider one is used in small factories. And the Siemens is, let's say, I'm not sure it's used in factories, but that's the kind of device that I would want to put in my home because it's quite cheap and it's easy to program. It has relay outputs. So yes, this talk also includes the device that you can find at home.
And then the problem of third-party management even becomes worse.
Yes, I recently, one of my clients, not on the ICS part, but a client recently told me that in his building, which is, how to say that, a shared building, the heating was remotely controlled by someone from the internet. So yeah, he was pretty scared for this winter. Okay. Next up, just a quick word about the ICSCERT. So it's a computer emergency and response team that is specific to ICS. It's quite interesting to take a look at least if you want to perform some assessment on ICS and you're looking for non-vulnerabilities in specific components. You have to go there and check the vulnerability built-ins. And also, actually, the ICSCERT is for the US. But let's say most of the devices used are the same, so the vulnerabilities are the same. And yeah, just a quick word about the study they published last year. They listed over 200 attacks on ICS, and some of them, around 80, were successful. So we also have to acknowledge that, yes, there are vulnerabilities, and yes, they are being exploited right now. Okay, so now we will focus a bit on what is a PLC. You have a question?
You said like 250 attacks. How are they being monitored? Because there was no active correlation or...
I think what they mean by 200 attacks is that, let's say somehow an incident was detected. It was not before the incident happened, it was after. Yeah. Okay, so what is a PLC? So as I told you before, it's made to manage input and outputs. It's some kind of real-time computer. It was invented to replace electrical relays because, let's say, a few dozen years ago, people were using electrical relays to perform the automation in plants and factories, but it was really expensive when you wanted to modify the process. You have to rewire everything, so that was costly. So that's why they invented PLCs. And also, last thing you have to know, these devices are rugged. That means they work in a harsh environment. When there is dust, when there is electrical noise, the temperature is not 18 degrees as in a data center. So it's quite different from a computer, but basically it's a real-time computer. On the right side of the slide, you can see the S7-1200, which is the smallest PLC that I have. You can see the inputs, the outputs. There is a network connection for Ethernet, and there's the power. If we take a look at the same device, but we try to look what's inside, we see that there's the hardware. On top of it, there's a firmware or an operating system. For example, on the Schneider, the operating system is VxWorks, so it's a real-time operating system. Then you have some application. Most of the time you have a web server, sometimes an FTP server, SNMP server. And on the other side, you have, let's say, the logic that you program into your PLC, and that is run through a middleware. So in the past, I know that some people have discovered vulnerabilities into those middleware, and that allowed them to compromise several PLC because they all some of them rely on the same middleware. Okay, so to understand how a PLC works, it's also interesting to know how you program a PLC. So the first programming language that was used and that is still used today is what we call the ladder logic. It was called like that because it mimics the look of, let's say, an electrical wiring diagram. You can see an example on the bottom left. But since then, there was a standard published that defines 5 main programming languages. I'm not going to detail them. I'm just going to show you the example. So on the left, the ladder diagram, which mimics the let's say, real devices. Then in the middle, you have the structured text example. So it's like programming in a classical programming language. And on the right, you have the instruction list example. So as you can see, it looks like assembly. So maybe now I'm trying to show you how is programmed the Schneider PLC. So you have a real example. Yeah, I'm just going to set up my screen. Can you see at least somehow? So now I'm connected to the PLC, the Schneider one. So that's the one on top. I'm going to transfer the program from the PLC to my computer. It should work. I'm sorry, everything is written in French. When you're using that kind of software, you have to have a big screen because there are some, let's say, windows everywhere. By the way, that's Unity Pro. That's the programming software that you have to use for, let's say, most of the Schneider's PLC. So let's take a look at the code. It's really basic, just to show you an example. So as you can see, there are some lines that are green, the other one are red. Basically, green means electricity is flowing, and red means that's not. So, for example, here, one light is lit because I just put this output to on, and the two other are switched off because light 0 and light 1 are set to 0 at the moment. So basically, if I just delete this one, So that's ladder logic, as I was explaining before. Now I can transfer it to the PLC.
So you can actually download the source code directly from the PLC.
Yes, mostly we will cover that in the second part of the workshop, because the way it's done by the software is quite funky. But yes. And it's absolutely not working, is it? Ah, maybe it's on stop. Yes, so now it's lit on because the electricity is flowing. So I'm just going to go back to what I've done previously, if I can. Okay. Okay, so basically that was just to give you an idea of how it works, how it is programmed. Let's say the people that I met mostly use ladder logic, but I'm sure it depends on the company and the specific policy about that. Okay, so let's go back to the slides. Okay, so next topic, I mentioned the usual lack of network segmentation, and I just wanted to give you some example of what a real lack of segmentation looks like. That means, can we find Scada on the internet? You may know that the answer is yes. To do that, I will demonstrate using Showdown. I'm sure you've heard of it. Showdown is basically a search engine that scans the whole IPv4 addresses all the time and allows you to, let's say, search some specific devices or some specific versions of software. So it's mostly free, while you have to pay to export all the results. What else can I say? Yes, in my personal experience, if I just buy a virtual machine on Amazon Cloud and I start an Apache server, within 2 hours it has been, if you take a look at the logs, within 2 hours it has been scanned by Showdown. So that's quite efficient. Of course, you can find some funny things. You can find PLCs like the Schneider and the Siemens. You can find some webcams. You can find some printers, some fridge maybe. They also have a quite good report on ICS. So they try to crunch all their data to find how many ICS can be reached from the internet. However, you have to know that Showdown works in an opt-out mode. That means if you are an ISP and you do not want your IP addresses to be scanned by Showdown, you can ask. So basically what you can find on Showdown is not let's say the whole perimeter. It's only what they are allowed to scan. So if you want to do it yourself, there are quite some tools, ZMap, MassScan. There's also a French tool called IV. And I'm sure you can find some other online services that do the same. That's one example I once saw on Twitter. So there was someone scanning the internet and finding this Scada system, which is actually a crematorium. So that was freely accessible, and you can start the fire and everything. So that's, let's say, the most funny example I have. But I'm gonna try to connect to Showdown to show you if you can find some devices as the Schneider or maybe as the Siemens. Just looking for my phone because I heard that the Wi-Fi is not working that well. Okay, let's see if it works. Yes. So basically, that's the new version of Showdown. You have a new user interface. That's quite funny. So let me input M340, which is the model of the Schneider PLC. So yes, they found some. I'm going to filter by the countries. I'm going to check out the ones in France. So there are not a lot, while even 40 PLCs connected to the internet is quite strange. As you can see, some interesting information can be found using Showdown. So you have the name of the project and other things. Let's click on detail, maybe on this one. It's random. I do not know this one. Okay, so the port that was scanned was the SNMP1. So some information were sent back. That's not really interesting. You can find some that have Modbus enabled. So I'm sure we should find some. Yes, this one, for example. Everything is open. Great. So you have the FTP port. So you have the list of available commands. You have the web interface. We're going to take a look at that later. SNMP, of course, and Modbus, which allows you to have a precise version of the CPU, as well as the version of the project, and that's all. So let me just see if it works. Seems to work. Yeah, I'm going to try another one. I did not prepare that, but I was sure to find some. Sorry. Nope, no luck. No, this one. Okay, so this one has even the telnet port, which is great. As you can see, it's VxWorks, as I told you. Actually, I do not know how it's possible to have telnet enabled. They succeeded, apparently. So yes, so that's the real web interface of one PLC somewhere in France. I'm not going to try to log in with the default credential. I'm sure that would be pretty illegal. And I'm going to do the same with the other kind of PLC that I have, which is the Siemens S7-1200. So yes, not a lot, but we can find some. With a lot of open ports as well, still in France. So you have FTP, you have HTTP. That is strange. They must have some kind of port forwarding there, because that's not the web interface of the Siemens. But there is the specific proprietary protocol, S7 on port 102, so that's also quite dangerous. And just to finish, this new version of Showdown is quite great, because of course you can see the results on a map if you pay for it, I think, but you also have an exploit tab which allows you to have the list of exploits that may or may not work for those kind of specific devices. So yeah, it's really all-inclusive. And let's go back. Okay, so that was all for the first part, which was the introduction. Do you have any question? If no, we're going to switch to the second part, which is that's a description of the Modbus protocol to understand how it works. Yeah, I do not have the text on my computer. So, Modbus is a serial communication protocol. It was invented a long time ago. I think it was 1979 by Schneider Electric. It was made specifically for industrial applications, and it was royalty-free. That means if you were developing some PLCs or other kind of ICS component, it was free to implement Modbus protocol. That's why now, at least in Europe and at least in France, it's one of the most widespread industrial protocol. It works in a master-slave mode. That means the master has to pull the information from the slave at a regular time. You can only have around 250 slaves per Modbus master. And also you have to know that the data that you get is without any kind of context. So you have to know if you are querying a signed integer or an unsigned integer because you just get the value, not any kind of object or description of the data. Security, anyone? No, not really. As I told you before, it's the case for most of industrial protocols. So it's clear text. There is no kind of authentication. So let's say if I have a cable that is plugged to a network on which there is a Modbus enabled device, I can freely ask for some data and also set the data. Mostly Modbus was invented on serial it was a serial communication protocol, but now since people tend to use classical Ethernet networks in the plants, there is a Modbus TCP version of the protocol that actually implements all the same security features. So yeah, it's basically the same protocol over TCP. If we take a look at what a Modbus TCP frame looks like, there is a transaction identifier that helps making sure that when you get a response from the device, it corresponds to which request. Then you have the protocol identifier, which is not really interesting because it's 0 all the time. You have a field for the length of the remaining length of the packet. You have the address of the slave. So as we're talking TCP, there is already the IP address that is used to know to who you're talking to. So actually, most of the time, it's 0, 1, or 255 that is used when dealing with Modbus TCP. And then you have the function code and the data. Now let's see which are the most basic functions that you can find in Modbus TCP. So there is two big kind of data. You have a coil, that means a 0 or 1, and you also have what they call a register that stores some kind of word that are 8-bit long. So the most basic function allowed to read and write to coils and registers. I took this table from Wikipedia, so if you want more information about what kind of function you can find on Modbus, go to Wikipedia. It's not only read and write, there is also some kind of diagnostic functions. You can, in some cases, depending on the implementation, you can also read some files from the device. And of course, some of the function codes are not documented and are used by some manufacturer to perform some things. Okay, so now what we can do is try to understand how Modbus works by taking a look at network capture. So did anyone succeed in getting the USB key and the virtual machine? Take that for a yes. Okay. So if you do not know it, the account name is root and the password is root reversed. So that means TOOR. Okay. So in the files directory, you should be able to find modbus1.pcap. Of course, you have the classical warnings because you are running Wireshark as a root, which is really not such a good idea. So the first thing we can do is, let's say, try to filter out only the Modbus communication. So we can filter by TCP port. So the TCP port used by Modbus is 502. So that was pretty useless since in this precise capture I gave you only Modbus communications. But anyway, you can see that we have a three-way TCP handshake. And then we have the first Modbus request. So we can see that it complies with the description I made earlier. You have one transaction identifier, protocol identifier 0, 6 remaining bytes, and the unit identifier is 1. If we now take a look at the Modbus payload, we can see that the function code is 3, which means reading registers. Reference number means the address of the data, and here it is 0, so it's the first data. And we want to read 16 words. Okay, and if we take a look at the answer from the device, you see that the transaction identifier is exactly the same, so that's the right answer. It's actually quite longer, which is a good sign because we asked for 16 words. Function code is the same, and then you have several values. Is that clear for everyone? Okay. So if I go back to my slide, I think I was asking a question about the value, a specific value. Yes, so in the capture you can see that there are some other requests, and I would like to know if you're able to tell me what's the value of the register number 1, 2, 3 at the end. So if you can take a look at the file capture. It's quite easy, you can just scroll to the end, and it's kind of the last packet, I think. So as you can see, Wireshark actually has a pretty good dissector for Modbus protocol, so it's really easy to understand how it works. So you have several queries, the answers. Did somebody find the answer? Okay, I'm just going to tell you then. Let's see. Fuck. Okay, so here we are asking to read some value, and I think that's the good one. Yeah, that's actually this one, and then I'm going to explain to you why. If we take a look at the query, we asked to read some registers, and the reference number was 120, so we wanted to read 120, 21, 22, and 23. And if we take a look at the answer, which bears the same transaction identifier, we can see that the value is 57,005, which means if you take a look on the bottom of the screen at the X value, it's actually dead. So that was the answer. You have to know that depending on the software implementation, sometimes the register address starts at 0, sometimes at 1. So that's also something you can take into account. Okay, I think there will be a break in about 10 minutes, if I'm not wrong. So what we can do is do another exercise on Modbus, this time using a Modbus simulator. Yeah. So included in the virtual machine, you have Modbus PAL, that is a Java Modbus simulator. It allows you to, let's say, if you're developing some specific tools or you're trying to understand how Modbus works, it's quite interesting to have a simulator because you do not have a PLC all the time just around. So to launch it, it's quite easy. You just go into the right directory, which is tools, and then you input Java -jar and the name of the program, which is Modbus PAL. And I'm going to walk you through it. Okay, so we go to the tools directory, and then we start the simulator, which actually has a nice GUI. Yes, here it is. Next, the first thing to do is to try to add some slaves because, as I mentioned before, it's a master-slave protocol. So I'm just going to add one slave. You put any funny name that you want. Okay, so you can add a second one if you want. That doesn't matter. Okay, so let's see if I want to modify the values of this first slave. I'm going to click on the big eye. And then you see you have several tabs, one from the coils. So I'm going to click on add, and then just next, add. So you see now I have, I can modify the value of all the coils. So I'm going to do it. Let's see if I try to input 5. Actually inputs 1, since as I told you the value is 0 or 1 for a coil, and for a register you can do the same. You add and then try to modify some value depending at the address that you want. Once it's done, you just close the windows, click on run, and then you have a Modbus device listening on localhost. So that's kind of convenient. There are two tools that we're going to use to perform those queries, but maybe, yeah, let's say just one before the break. It's a Perl tool that is called mbtget. So if you want to take a look at the source code, you can. So it's a command line tool. It's quite easy to understand. It's also in the tools directory. If you want to perform some requests, you use the R1 switch for the coils and the R3 switch for the words. Then you have to pass the address, of course, the number of words or coil that you want to read, so that's the N switch, and then the IP address. Okay, let's see. So I'm opening up a new tab. So let's see. I will use the R1 switch to read the value of some coil. Starting at address 0, and I want to read 8 of it, and then I just input my IP address. And you see that the values are 1, 1, 1, and then only zeros. I'm going to do a double check by looking through the GUI on the coils, and you can see that I have 1, 1, 1, and then only zeros. So I'm just going to modify it. And if I perform the same request, the first value should be 0. And it is. Does that work for those of you who are performing the test? Sorry? Which one, the Modbus PAL? Okay. Because it runs on port 502. Yeah, sure. That's why we do not have those kind of problems in Kali, since you're running everything in root, which is a very bad idea, of course, from a security point of view. Okay, so let's do the same kind of request on registers, which stores, let's say, longer values. So you can see that I have 1, 2, 3, 4, 5, and that should be the same if I take a look at here. Yes, that's the same. I'm just going to change the 5 to 6. And it works. Of course, if I want to, I can also modify the value by using the switch W6 and inputting any address, let's say address 1. So it's a worldwide OK. And if I take a look in the GUI, I have 12 address number 2, whereas I ask for address 1, which is a different, because there is an offset in the, let's say, as I told you, some software use 0 as the first value, some other use 1 as the first value. So is it working for everyone? Do you have any kind of question? Nope? Okay. Just continue and try to modify a coil, because that's another possibility. I do not remember the exact command, so I'm going to take a look at the help. So if you want to write a bit, it's W5. Okay, so that should have worked. It's 1, and if I do the same with the value 0, then it's 0. Okay, great. I think if you do not have any other question, we can take our break. What are we going to do after the break? We're going to do the same kind of request using Metasploit, because there is an integrated Modbus client auxiliary module. And then after, I'm going to try to set up a Wi-Fi network, so those of you which are interested can perform the same test as me on the real devices. And by those tests, I mean performing some kind of recon using Nmap or PLC scan. Then we are going to use the same tool, MBTGet or Metasploit, to perform a Modbus request to the Schneider PLC. And then I'm going to try to show you let's say 1 or 2 vulnerability in the Schneider PLC that allow an authenticated stop and start, and maybe we can try to retrieve the program without being authenticated.